So now I want to introduce just a new mathematical term here that gets used frequently when doing these present value calculations. So in the previous example, we saw that the present value based on this formula is just the future value divided by 1 plus I to the nth. We can further break out, if we rearrange this just a little, so it's the future value times 1 over 1 plus I to the nth. We're left with this term in brackets, and that's highlighted, 1 over 1 plus I to the nth. And algebraically, there's nothing changed. We're just rearranging things just a little. And we give this term a name, and it's called either the present value interest factor. You'll also hear it called the present value factor. And it gets used, you'll see it in occasion to help in calculating these present value calculations. So let me talk a little bit more about that. Let me give you an example. So we have our $2,000 from the previous example, and we're discounting it, right? So we say it's $2,000 divided by 1.12 to the third. Now we're going to introduce this present value interest factor. So it's 2,000 times 1 over 1.12 to the third, which just reduces to 0.712. So it's $2,000 times 0.712, and we're left with our 1424. So why is that interesting? Well, let me just summarize what we've got here. So we can say that the present value is equal to the future value times the present value interest factor. And we can even put a couple of notations there for a given interest rate, for a given period of time. All right, so this is actually very easy conceptually to see, and we can then see that you can change the interest rate, you change the period of time, and those are the main factors that cause the future value to change. That influence the future value to become the present value. So I'll give a couple of more examples of this. So let's say we have $5,000 3 years out, and we want to figure out what is that worth today. And we have an interest rate, we're told, of 7.5%. So let's say let's start with this formula. The present value equals the future value times the present value interest factor, IN. We substitute our equation, and that reduces to $5,000 times 0.805. So you can actually, some financial calculators or tables and textbooks will actually have details of the present value interest factor. So you can see in the back of the textbook or whatnot, big tables that help you calculate this. This is more of a traditional method. So then that reduces to 4,025. Again, conceptually, what this is saying is we are indifferent to receiving $4,025 today or $5,000 in 3 years given an interest rate of 7.5%. We're equally happy with both of those. It sounds a little counterintuitive the first time you see it. $5,000 is obviously bigger than $4,025, but in this case, the difference is 3 years and 7.5% of cumulative interest. So when you equate those two, they're identical terms. All right, let me give a little bit more with this present value interest factor. So what is the present value of $10,000 in 5 years, assuming an interest rate of 6%? So I'm just going to plug it in. That's 10,000 times 1 divided by 1.06 to the fifth, or simply 0.747, which is 7,470. All right, so we'll come back to the present value interest factor a little bit more shortly. This is, it's really more just a little bit of mathematical manipulation, and I'm kind of priming the topic even more. We'll discuss it and see why this is helpful shortly.